What is amps in computer science? How do amps apply to your computer? Today, we're diving into the world of amps and how they relate to our beloved computers. You might be thinking, amps, isn't that for electricians? Well, yeah, but it's also important for understanding how much power our computers use. And with energy costs rising, who doesn't want to save a few bucks on their electricity bill? Knowing a bit about amps can help you make smarter choices about your computer setup. You can choose components that are more energy efficient. This can help you save money in the long run. Plus, understanding your computer's power draw can help you avoid overloading circuits and tripping breakers. Nobody wants that. So let's get started and demystify the world of amps. By the end of this, you'll be able to impress your friends with your newfound electrical knowledge. All right, let's break down what an amp actually is. In simple terms, an ampere, or amp for short, is a unit of measurement for electrical current. Think of it like a river. The water flowing in the river is like the electrical current. The more water flowing, the stronger the current. Similarly, the higher the amperage, the more electricity is flowing. Now, voltage is another important factor. Voltage is like the pressure pushing that water through the river. Higher voltage means more pressure, which can push more current amps through a circuit. And to complete the analogy, resistance in a circuit is like the rocks and obstacles in the river that slow down the water flow. So how do amps apply to your computer? Well, every component in your computer, from the CPU to the graphics card, to that little LED light on your keyboard, needs electricity to function. Each of these components draws a certain amount of current, amps, to operate. The more powerful the component, the more amps it typically draws. For example, a high-end graphics card running the latest games will draw significantly more amps than a basic integrated graphics card. The power supply unit, PSU, in your computer is responsible for converting the AC power from your wall outlet into the DC power that your components need. The PSU has a specific amperage rating, which indicates the maximum amount of current it can safely deliver to your components. Different computers, different amps. The total amperage draw of a computer can vary greatly depending on its components and usage. A basic office desktop computer might only draw 2 to 3 amps, while a high-end gaming PC with multiple graphics cards and a powerful CPU can draw 10 amps or more, especially under heavy load. Laptops, on the other hand, are designed for energy efficiency and typically have much lower power consumption than desktops. A typical laptop might only draw 1 to 2 amps, even under heavy load. It's important to note that these are just rough estimates. The actual amperage draw of your computer will depend on the specific components you have and how you're using it. Ampere computing, a new player. Now you might be wondering where the name Ampere is named after the French physicist André-Marie Ampère, and Ampere is also the standard international unit of electric current representing the flow of 1 coulomb of electric charge per second. And also Ampere computing is a big deal in the tech world. Well, there's actually a company called Ampere Computing that's making waves in the industry. Ampere Computing focuses on designing energy-efficient processors for cloud servers and data centers. They're all about delivering high performance while using less power, which is pretty awesome considering how much energy these massive data centers consume. While you won't find Ampere CPUs in your gaming PCs just yet, their focus on efficiency is definitely something to keep an eye on. It shows that the industry is moving towards more sustainable computing solutions. Saving energy, saving money. Now that you're an amp expert, well, almost, let's talk about some practical ways to reduce your computer's energy consumption and save some money on your electricity bill. First, make sure you're choosing energy-efficient components. Look for the Energy Star label when buying new monitors, power supplies, or even entire computer systems. These products meet strict energy efficiency guidelines set by the EPA. Another easy tip is to adjust your power settings. Set your computer to sleep or hibernate mode when you're not using it, and dim your screen brightness when possible. These small changes can add up over time. Finally, consider upgrading to a newer, more efficient power supply. Older PSUs can be less efficient at converting power, meaning they waste more energy as heat. The future is efficient, so there you have it. Hopefully, you now have a better understanding of amps and how they relate to your computer. Remember, every little bit of energy saved counts. And by making smart choices about our technology, we can all do our part to reduce our environmental impact. As technology continues to evolve, we can expect to see even more focus on energy efficiency. From new processor designs to innovative power management techniques, the future of computing is looking greener. And that's something we can all get excited about. Until next time, stay efficient, my friends. If you like this video, please subscribe.